Welcome back to Polar Graphing. In this video, we're going to finish off section 10.8, polar graphs. This is our last example, sketching a lemniscate. Let's go back here and review real quick. Lemniscates, the other ones were r equals and r equals. These will have an r squared equals, r squared equals. The shape kind of looks like the infinity symbol or a number 8 that does go through the origin. And I'll explain how that shape occurs as we work our way through the example and today's practice problem. All right, sketch the graph of r squared equals 9 sine 2 theta. If I do take the square root of the left side, I would get r. If I take the square root of 9, I'll get 3. And then I'm going to have a root over the sine of 2 theta. So if we fill in this, the type of curve is a lemniscate. Symmetry. Let's talk about the symmetry. Let me come back here. We will do our 3 tests. Let me make this slide a little wider. Okay, so the function is 9 sine 2 theta. 9 sine 2 theta. And a quick review. In the last video, we talked about the cos of a negative angle is the same as the cos of the positive angle. Cos is an even function. In class, you might have heard me say that cosine here is hungry and it loves to eat negatives, so that negative gets gobbled up and it's gone. Now, sine is odd, so the sine of negative theta would be equivalent to the negative sine of positive theta. So cos is hungry, it eats negative. Sine is not hungry, so this negative just escapes out in front. So that'll be helpful as we're simplifying some of these in our tests. The first test is for the polar axis, also known as the x-axis. We are going to replace theta with negative theta. Theta to negative theta. So this 2 theta will become negative 2 theta. Once again, this negative can escape, but it's not going to disappear. It's going to wind up out in front. So we simplified, and we get this, and it is not the same as what we started with, so there is no polar symmetry. Next will be y-axis, or theta equals half pi in terms of polar stuff. We're going to replace theta with pi minus theta. So we're going to have 9 sine of 2 times quantity pi minus theta. I am going to distribute the 2. I'm going to go to the negative theta first, so we'll have negative 2 theta here. And then 2 to the positive pi is plus 2 pi. And we all know that a trip around the unit circle is 2 pi radians, so this would just take us around and leave us back where we started. So I'm going to put a parenthesis here. Our negative sign in here will once again escape, and now it's in front, and that is what blows up our symmetry. We are not back to the original equation, so we do not have y-axis symmetry. Finally, we're going to do pole symmetry, also known as the origin. We're going to replace theta with pi plus theta, or theta plus pi. It doesn't matter what order we add in. So we're going to have our 9 sine of 2 times pi plus theta. And I'm going to distribute that 2. And I'm going to do the theta again first, so that'll be 2 theta plus 2 pi. And once again, 2 pi is a trip around the circle, so that goes away. I'll just put my closing parenthesis there. And finally, we have matched our original function. So we do have origin symmetry, or pole symmetry. Oop. All right. Something else that we need to take into account on this special function, and it all comes from this radical right here. We cannot have negatives under our radical, so we've got to find out and be sure where sine of 2 pi, just the stuff under the radical, is positive. So we need sine of 2 pi to be positive. Oops. So sine, having a little glitch here, sine of 2 pi positive. From my opinion, the easiest way to figure this out, let's just graph it. We're going to graph a sine wave. When we graphed sine so long ago, we would find the amplitude. The amplitude is the number in front of the trig function. There's a 1 there, so we're going to go 1 to negative 1. And we would find the period of the function. Period of sine and cos is 2 pi divided by the number in front of the variable, 2. So these are going to cancel. Our period, a 1 cycle of sine of 2 pi, will roll out from 0 to pi radians. So I'm going to eyeball this, cut it in half, pi over 2. Cut 0 to pi over 2 in half, that's pi 4. 1/4, 2/4, 3/4 is here in the gap, 3/4 pi. And then we think back, okay, it's a sine wave. We are going to start at the origin. We will end the cycle 1 pi later. There's our beginning and ending points. We will cross the x-axis in the middle, and positive sine begins by going to a peak, and then we come down into a valley. So again, we don't want these negative output values. They would put a negative under our radical. So we're more concerned with finding stuff between 0 and half pi. And here, our table that we're going to fill in, we go from 0 to half pi. If you look down here in the book, you know, they did find this cycle. It would also occur again from pi to 3/2. But with the symmetry that we found, these values here will be plenty. So I would put that in my graphing calculator. 0 goes in, 0 comes out. Pi over 12 goes in, 2.1 comes out. Pi 4 goes in, we get a 3. 5 pi over 12, that's just less than half pi, also gives us 2.1. Half pi takes us back to 0. So it does look like we go from the lowest value to the highest value and then back to the lowest. Let's graph these points on the polar graph and see what this is going to look like. And remember, we do have origin or pole symmetry. Again, here these decimals are 2.1s. So the first one, 0, 0. You're going to put a dot at the origin. And that also tells us that we kind of have an asymptote running across 0 radians. So our graph should not cross that axis. And since I got the tool out, let's do the pi over 2. Whoa. The pi over 2 asymptote, also down the y-axis. Now let's do some points. Pi over 12 is halfway between 0 and pi 6. We're going to go out 2.1, 1, 2, and then 0.1 would just be right about here. And we do have our origin symmetry, so we can go straight across the origin, go 2.1 units here, and I'll use the red dot for that symmetric point. All right. Up next, pi over 4 plus 3. Well, pi over 4 would be right here between pi 6 and pi 3. We're going to go out 3 units, 1, 2, 3. And that will reflect across the circle over here to 5 pi over 4. And we'll go out 1, 2, 3 units. So there's our symmetric dot. And then finally, I'll go back to blue ink. 5 pi over 12 is just under a half pi. So we're right here, 5 pi 12. And we're going to go 2.1 units, positive. 1, 2, 0.1, just a little bit over that line. And again, the symmetry would take us across the origin and right here. And there's all the dots that we need. Our first flower petal will be here in quad 1, like so. And our next one will be down here in quadrant 3. And there's our graph. There is no graph over here because these values would give us a negative under the radical. Same thing here in quad 4. Any angles down here are going to give us a negative under the radical. Function is not defined, so it's nothing to graph. Okay. So there's our example. And now we're going to try this single checkpoint. It's r squared 4 cos 2 theta. This will also be a lemniscate. And if we take the square root, we're going to have r is square root of 4 is 2. And then we're going to have a root of cos 2 theta. So we got to figure out some stuff with this. Let's look at the symmetry and where this cos of 2 theta is positive. So let's do let's do the symmetry first. So our function here is 4 cos 2 theta. Let's check our symmetry. So the first one I like to do is polar axis, x-axis. And we're going to take out that theta. Wow, getting a little glitchy here. We're going to take out the theta and replace it with negative theta. So that'll be negative 2 cos theta. Negative 2 theta. Once again, cos is hungry. It's going to eat that negative up. So we're back to our original equation, and we do have polar axis symmetry. Now let's check pi over 2 symmetry, y-axis. We are going to take out the theta, and we're going to replace it with pi minus theta. Once again, I will distribute the 2, and I'm going to reverse this order. Negative 2 theta plus 2 pi. The plus 2 pi just takes us around the circle one more time. Cos is even, so this negative gets gobbled up, and we're back to where we started. So we also have pi 2 symmetry. And then finally, we'll do pole symmetry around the origin. And we're going to replace with this, but we're going to change that to a plus. So that's going to be cos of 2 times. I'm going to write it as theta plus pi. Distribute the 2. Cos of 2 pi, or 2 theta, plus 2 pi. 2 pi, again, just another trip around the circle. And we are back to our original function. So here we have all 3 symmetries. Now we got to figure out where cos of 2 theta is positive. Cos 2 theta positive, question mark. Okay, well our amplitude is just going to be 1, and the amplitude really doesn't matter. We're just trying to figure out where we dip below the x-axis. And our period is going to be 2 pi divided by the number in front of the variable, 2. So our period, once again, is pi. So I'll put that as pi, half of that, quarter pi, 3/4. And let's graph a cos wave. Remember, positive cos starts up here at a peak. It'll be at a maximum value. 1 pi later, the cycle is over, and we're at the same maximum value. Pi over 2 is our valley, and we will cross at pi 4 and 3 pi 4. So again, we want to be above the x-axis, so this is a good area, 0 to quarter pi. But then we dip under. We don't want to touch these values because that would give us a negative under our radical. And then here we are to finish off at pi. That's a good region. So we can go 0 to 1/4 and 3/4 to pi, and we should be good. And notice on the graph we crossed the x-axis at 1/4 and 3/4 pi. So here at 1/4, 0. 3/4 is also 0. All right, and when the 0 goes in, a 2 comes out. Pi over 6 goes in, we get about a 1.4. 5 pi over 6 goes in, and we get the same 1.4. So if I want, I can plug in some asymptotes. We got a 0 at quarter pi, so there's quarter pi, and another one at 3/4. So there are some lines we will not cross. And remember, we also have all 3 symmetries available. So 0, 2, we're going to 0 rad and go out 2 units. The x or the y-axis or the origin symmetry is going to take me over here to this same dot here. And now we've got pi 6, 1.4. So I'm going to go out the pi 6 ray about almost between 1 and 2 there, about 1.4. Now this, we're going to apply all the symmetries. So x-axis will take me down across the x-axis to here, back to the original point. Across the y-axis is going to take me over to here. And the origin symmetry will send me across the origin to right about here. When we have all those symmetries available, look at these 4 dots kind of make a rectangle. So I know I got them all in pretty much the right spot. Oops, there we go. 5 pi over 6, we kind of already got that. 5 pi over 6, we did reflect that across. So I guess we really didn't even need that point. Maybe next year I'll just do it with these 3. I guess that's enough to get us started. But we can see here, counting when we cross at the origin, we have a petal out here in quadrants 1 and 4. We have another petal going over here in quadrants 2 and 3. And there's our graph of a lemniscate. And that finally is the end of our polar section graphing section. I hope you enjoyed the videos.